Welcome to Chapter 11, Inheritance and Polymorphism. Inheritance is about superclass and subclasses. It's about how a class uses the property from the other class. Inheritance in Java begins with the relationship between two classes defined like this. Class, subclass. Any class name over here, that's the class you would like to design. Extend, superclass. That's the class you would like to take over their property or member data field member methods. Inheritance expresses the is a relationship in that subclass is a specialization of superclass. The extend relationship has many of the same characteristics of the implement relationship used for interface. A subclass could be a boy, extends superclass could be a person, and another subclass could be girl that extends the same person class. Interface is a different thing. Interface is not a class, but it is also a group of methods that you can take over. It is similar to class but different. In between the interfaces, you need to use implement instead of extend. My implementation class will implement the methods of my interface. So interface is a group of methods. We call it interface. Interface is not data entity. Class is, superclass is. As with inheritance, we say that my implementation class is a my interface. Inheritance, diagrammatically, these relationships are expressed in UML with the extend as a solid line, so it's a solid line. And in this diagram, it's used dark arrow, but in other tools like BlueJ or the tool we recommend for UML, the violet, they use white triangle. And the implements use dashed line and the arrow. The is-a relationship is transitive. That is, we have this hierarchy. So if class C extends class B and then extends class A, then C is also extending class A. As shown in the figure in the previous slides, in which class B is a class A, class C is a class B, then by transitivity, class C is a class A. The term-based class, in this case would be A, is also used for superclass, and the derived class a subclass. So A is a base class and also a superclass. B is a derived class and also subclass. And in second case, B is also a superclass. C is a subclass. B in the subclass is also transitive in that we can say that class C is a subclass of class A. The term inheritance expresses the fact that the object of subclass inherit all the features of superclass, including data members and functions or methods, although the private data members and the functions of the superclass are not directly accessible. Remember, private data member and functions are not directly accessible but can be inherited. What does a subclass inherit? A subclass inherits all the members, field, method, nested class, or inner class from its superclass. So all of the data, private, public, protected, or inherited. Constructors are not members, so they are not inherited, but the constructor of the superclass can be invoked from the subclass. So constructor is not inherited but can be called. Members of a class that are declared private are not directly accessible by subclasses of that class. Only members of a class that are declared protected or public are accessed directly by subclasses declared in the package other than the one in which the class is declared. So if it is default, only classes of the same package can access the default variables. Protected means no access by other package but can be inherited by other package. That's a definition for protected. Visibility modifier, public, protected, default, or private all be inherited. But access, public is for all, protected only for subclasses. Default, same packages. Private, same class. Here is a conceptual diagram for how to access objects of subclasses. Subclass is another kind of wrapper class. Say right here, class B inherits class A, and class A has one private data field A as integer, one private method F function, and one public method get A to get the data here, and then one public data field B as double field. In this case, the object of this class cannot directly access the A variable, but A variable can be accessed by get A as a public method, and B variable can be accessed by outside world directly. When this A class is inherited by B, then the properties of A got copied over. For the private data, it still cannot be accessed by the outside objects or programs from B class objects. But the public method or public variable inherited from A class still be public, so they are accessible by the object of other classes. And class B's data is added on the class A so that the total data field has A, B, and C, and A and C are private now, and D and B are public now, and the client method that's private for A class and the client method for BH method both are still private, and then the get A, get C two methods are public, no matter it's inherited from A class for get A or it originally available for get C in class B. So this diagram shows you how class A is wrapped by class B, and class B take over all of the data and method from class A, but private and public are treated differently. And protected is another way you can access the data or the methods. It's just that you can only access the variable from the subclasses of the class. Superclass and subclasses. We have a superclass called geometric object, and the data field is the color, field, and the date created. And here are the methods to access the color and field setting, and the toString to print out the data. And here are two derived data class, circle and rectangle. Each class is a template for other objects. Circle, you have radius of double. Geometric object doesn't have. Here are the constructor is new, different from the geometrical object. And the constructor are not taken over anyway. Right here, we have different accessor mutator for circle. Rectangle, we have the constructor over here, the accessor mutator over here. So when we declare a subclass, we have a constructor doesn't call in any constructor from the superclass. A default superclass constructor would be called in the constructor of the circle. It is done implicitly. So let's go to Bootj to take a look on the program. Right here we have 4 classes, 1 test class, 3 data classes. This simple geometric object is the superclass. So just like the description in the UML, it has the color field and the created date, and some methods like this. And let's pick another class from circle from simple geometric object. Right here, it extends the simple geometric object and has a private data field radius. Say, here are 3 data fields, and the constructor did not call the superclass constructor. But anyway, implicitly, these 2 constructors, when they are called, it will call the default constructor without any parameter list. So this one will be called. Even this one was overridden by user-defined constructor. And right here is a long form of the constructor. Here is another long form constructor. But they are the same. You need to repeat it, because this long form will not be taken over by the subclass. You need to redefine the color and field if you call the long form. Right here are the accessor mutators. Let's look at the test class. The test class actually create one circle and one rectangle and use the long form constructor right here, and then access the data field and print them out. Let's check the data. Right here we have the execution result. Print the circle to string. You'll use the toString method by the superclass. So you will print out the they created color and field. So they created color and field. So the first statement toString right here for circle and rectangle, they print out both from the method using the superclass. And this private data field accessor mutator by circle and the rectangle, they print out the data from the subclasses methods. And we have the result right here. The circle and rectangle have different data field and different accessor mutators. So this program shows you the relationship between superclass and the subclasses. Superclass constructors are not inherited. They are invoked explicitly or implicitly. If you want to invoke it explicitly, you need to use the keyword super. If the super is not explicitly used, the superclass no argument, that's a default constructor, is automatically invoked. Superclass constructor is always invoked, especially for the no argument one. So you need to set the default setting very carefully, because the default setting in the super constructor without argument will always be called by the subclasses. So this one is equivalent to this. This one is equivalent to this. They will automatically call in the no argument constructor. For the same long form, they will call as well. Let's go to the valid UML editor. In this valid UML editor, I will show you how to construct the class diagram for this example. I have listed down the data field, constructor, and method for each class. Right here, let me show you how to do inheritance. Click here, you click the subclass, drag to the superclass. An inheritance relationship is formed. Click again, another subclass to superclass. It is also formed. And if you want to declare a use relationship, click it, starting from the using class, that's the tester class, to the used class, or aggregated class. A relationship form. And then this one also using a rectangle, so let's drag it as well. After they are done, click select, pick one relationship, double click it, and come out with a label setting. Starting is the using class, let me put in n, means that it's an n to 1 relationship. In the middle we use uses. At the end I type 1, and I want it a straight line. Okay. Similarly for this one. Starting label n, middle uses, at the end type 1, straight line. So this one I show you how to construct a UML class diagram for this simple geometric object and the circle and rectangle. You can download this to study it. Thank you, have fun!